Okay, folks, let's take a look at problem 4 from chapter 5. And this problem takes us away from working on break even and asks us to begin to think about cycle times and capacity. And in this case, we're presented with a problem where a product that's being manufactured is going to require 5 steps to manufacture it. And so it's going to take a certain amount of time to complete all the tasks associated with this product. And if we look at the product itself, the way it's described, it's a sequential product, 5 steps, A, B, C, D, and E, punching, bending, combining, painting, and polishing. And if we look at the total of all those steps, it's going to take 180 seconds, assuming we start and work on it continuously, to produce one product. When we think of a productive process then with just one worker, that worker is going to work continuously making products, and it will take 180 seconds from start to finish. And if we think of taking no break time, we can begin to think of exactly how many products this person can make in a particular day. We recognize we're generally not going to have one person working start to finish. And so we're going to want to divide tasks, set up some workstations to help make the flow more efficient. And we want to go through a calculation here to figure out just how many workstations we'll need given certain limiting factors, one of which is this 180 seconds. So let's work through the problem and see what we're doing. Now, if we think about this, when it comes time to analyze these, the first thing we want to take a look at is, again, assuming we just have that one person working the whole time by themselves, how much can they manufacture themselves in a given time frame? Well, we know that in a given hour, we're going to have 60 minutes, each of which will have 60 seconds available to produce a product. And if, in fact, we need 180 seconds to produce that product, we can then design an idea that says, well, we're going to have 3,600 seconds in any given hour, that's the 60 times the 60, available to produce, each one of which will take 180 seconds. So at a maximum flow rate where one person is working continuously, the most they're going to be able to produce is 20 units per hour. And that's going to be the maximum output that a person working continuously by themselves could produce. Now, we want to find a way to see how we can be more efficient, and we're also going to try and figure out how we can go about making the desired output for this firm of 400 units in a day. Now, if we just have one person working 20 units per hour, clearly that person cannot produce 400. We're going to have to find a way to add people or add workstations to make the most efficient use of the resources in our productive process. So the next step to figure out how we're going to do that is to calculate something known as cycle time. And this would be the amount of time needed to produce the product or complete the work at a given workstation. So when we go to calculate this, we're going to take a look at cycle time and recognize that cycle time becomes a relationship of all the time available to me. So available production time in a given day. And we want to relate that then and actually divide it by the number of products we need to get done in the day. So desired production per day will give us a relationship of how much we can get done in a given time frame. So if we take a look at any given day, we recognize that that day is going to have 8 hours, each of which will have 60 minutes available to us, which will include 60 seconds for each of those hours. And the problem tells us that within that time frame, we're going to want to produce 400 products per day. Well, that's going to suggest to us then that 8 times 60 is 480. Multiply that by another 60, and we've got a total of 28,800 seconds per day available for us. And we're going to relate that to our 400 products per day. And if we just divide that out, that's going to tell us that if we break this down into a sequencing or a number of stations at which we can spread the work, we're going to find out that every workstation, the number of workstations that will provide us the availability to do this, are going to have to allocate 72 seconds per station or per task at those stations. Okay? And this is just a measure, again, of taking our available production time, looking at how many units we're going to have to produce, coming up with the idea of how many stations are going to have to be available to us. Now, we can take this back now and take a look at exactly how that's going to work out, because we do know that when we go to calculate this minimum number of workstations to accomplish this, we calculated to start the problem that there's a certain amount of task time involved in completing the whole product. And what we want to do is relate that total task time to the cycle time that we calculated above. Okay? Because that cycle time reflects the number of products we have to get done in a given day relative to the workstation. So we know that we need 180 seconds in total task time to produce one product. We know that in order to accommodate 400 products in the seconds available to us in a day, there's going to have to be 72 seconds available at any given time for all the products to get that accomplished. And so if we merely divide total task time by the seconds in any workstation, it's going to tell us that we're going to need a minimum of 2.5 stations, allocating 72 seconds to each of those stations. So we divide the task up into 2.5 stations per. At 72 each, they can complete one unit in that setup. But of course, we recognize that we can't have a half a station, and so the solution to the problem becomes 3 stations, each of which are going to be working at 72 seconds per, is the minimum configuration we need to produce 400 products in a given day.